Okay, this video is going to be about stress and human health. It's going to be in a couple different parts. I'm writing a book chapter about it, and I'm sort of about 3/4 done, but I got to touch it up, and I figured I'd just make a video of it because that'll motivate me to touch it up better. So, first of all, what builds resilience in a person? People who are stoic, they're more resilient. People who have a strong sense of purpose, they're more resilient, meaning that they're more resistant to problems related to stress. People who are religious, any of the major religions, okay? Christianity is the best one, but any of the other major ones, the people are significantly healthy, more healthy. Harold Koenig wrote several books about that. People who are just in general good health, they're more able to tolerate psychological stress and other types of stress. Who get adequate sunshine. They get more vitamin D. Their vitamin D from the sun helps them to regulate their immune system. Their immune system functions better. And it also gives them better mitochondrial function, releases nitric oxide, subcutaneous precursors, so they have systemic vasodilation, good blood flow. They have better circadian rhythms. We're made, to spend part of our day outside. And biophilia, we enjoy being in nature. You get better circadian rhythms, you sleep better, your brain replenishes itself, cleans itself at night while you're asleep through the lymphatic system, so that makes you healthier. Having good relationship, like let's say with your parents, your siblings, your friends, your colleagues, whatever, some positive social relationships in your life increases your resilience, the social support system, having some money that you can afford to at least pay for the essentials of life. Having good fitness, getting some exercise. Just, try to at least walk every day at a minimum. Do some stairs, do some isometrics, do something. Just move in some positive way. Having role models. Role models are very helpful because a role model gives you something to aspire to. And the role model could be from literature, it could be from real life, somebody you've seen on the internet or a book or something. It's also good to have anti-role models, people you don't want to be like, okay? I know some guys who are pretty good guys, but, they really got screwed in their divorce. Like one doctor, he was moonlighting a lot with 2 jobs. So when he got divorced, his wife cheated on him. He had to pay double alimony. She cheated on him, caused all the trouble. And I know he loved her. And he had to pay double alimony, work 6 days a week for the next 20 years of his life. He got screwed. Okay, next one is have some heroes, kind of like role models. Self-esteem. If you do the best you can with your current situation, then you respect yourself, so you have good self-esteem. Have some adaptability. There's a lot of BS. You just have to roll with it sometimes in social situations. Try to maintain your friendships. Be a good friend and eat a healthy diet. That keeps you healthy. That makes you more resilient. So it's sort of like the thing that if you fall down, a healthy person falls down, they put their hands out, they're a little embarrassed, they shake it off, they're fine. An old person falls down, they'll fracture their wrist, fracture their hip, or something else. Okay, what is stress? Stress is a psychological response, physiological response to danger or to an excessive burden, physical or mental, placed upon us, time pressure, perceived tiredness. There's a little more to it than that. We'll get into it in a moment, but that's the general idea. Is stress ever good? Yeah, you need a little stress to energize you, to motivate you. So a little bit of stress is useful. Healthy stress is called eustress. Eu means like normal amount of stress. Excessive stress is distress, okay? Like, for example, teaching the Socratic method of questioning. That's good. It puts the student in a little stress. They'll remember that question better. You remember, like, when your father taught you stuff and he'd ask you questions, and my father would all say, "You just flunked your instant IQ test." I'm like, "Okay, Dad." Fun, but dangerous type of stress is called a mistress. Okay, here's the Yerkes-Dodson curve of stress versus performance. And again, you need some stress to motivate you for energetic, high-level performance. But if there's too much stress, then you're distracted. You're kind of overwhelmed. If you don't have any stress, you're not motivated. You're bored. It's like, being in a public school and the teacher's going blah, 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 blah. You're like falling asleep, looking out the window. Okay, so the idea is, how do you get yourself into the center, the peak performance zone? And, you have to figure that out for yourself. But all the things we talked about work. You're interested in what you're doing. You're motivated. You want to succeed. You want to excel. Okay, now how does stress kill people? Well, stress can contribute to a person dying because it's prothrombotic. The way you remember everything in stress is being chased by a tiger in the dark. The tiger might claw you or bite you and you bleed. You want to bleed to death, bleed out. So you want to clot. So you're more able to clot when you're stressed out. You have increased clotting factors in the blood, factor VIII, fibrinogen, the clotting protein. von Willebrand factor, and you'll have also increased platelet activation. Also, the stress shuts down blood flow to the gut, because the way you can think of stress is the body has limited resources of energy and where it's going to put all that stuff. So when you are resting, you're in parasympathetic autonomic nervous system phase. That's called rest and digest, feed and breed. Okay, it's a time to grow, it's time to repair an injury, all that stuff. But when you're stressed out, it's time for fight or flight, which is sympathetic autonomic nervous system. I usually refer to that as SANS, S-A-N-S, sympathetic autonomic nervous system. Okay, and that's fight or flight. So you need to run, climb a tree, throw a stick at the animal, the tiger chasing you, whatever. So you want to increase blood flow to your muscles. But in order to increase blood flow to your muscles, you want to shut down blood flow to the viscera. Viscera means your intestinal tract, things like that. So you shut down blood flow to the gut. Well, when you shut down blood flow to the gut, for just, 1 hour to run and climb a tree, not a big deal. But a lot of modern humans, they're chronically stressed day after day after day. And then you're going to have chronic shutdown of gut blood supply, and that's going to make the gut a little bit ischemic, hypoxic, lack of oxygen to the gut. And you can start to damage the cells of the gut. That'll cause leaky gut. Then some of the bacterial endotoxins get into the blood. So this is stress-related endotoxemia. Emia just means it's in the blood. Endotoxins are the bacterial chemicals, like LPS from gram-negative bacteria, LTA from gram-positive bacteria. Those then will induce a change in the secondary protein structure of fibrinogen, the blood clotting protein, going from alpha helix, like a slinky, a cylinder, to beta pleated sheath, flat like a deck of playing cards. And then they will form hydrogen bonds between themselves, and they will precipitate, which means to clot in the blood. So that is fibrinolytic clotting, also called amyloid clotting. The word amyloid just means a change in the secondary protein structure, okay? Because you're going to hear that word in other contexts, so you should know what it is. You should know what it is. An amyloid transformation is the change from cylindrical secondary protein structure to beta pleated sheet. So cylindrical meaning alpha helix to beta pleated sheet. Those are the two main secondary protein structures: alpha helix, beta pleated sheet. Okay, and so that makes your blood prothrombotic. Those can plug up little capillaries in your brain and your heart and elsewhere. You'll also get increased blood lipids because the body needs to mobilize energy, so it pushes glucose into the blood, so you got a lot more glucose available to run, climb a tree, to fight, whatever you got to do, and you also have more blood lipids available to burn for energy wherever you want to burn them. The heart will burn a lot of lipids. When you're stressed out, it'll start burning more glucose, but it can still burn lipids. The heart's used to running on lipid at rest. Okay, so what that basically means is after somebody just had a dramatically emotionally stressful event or was real angry or something, you don't want to stress them out anymore because they're kind of vulnerable at that moment, okay? The other thing is, while you're massively stressed out, running from a tiger, being chased by a tiger in the dark, it doesn't matter if you have a little low-grade infection, okay, toe fungus. It doesn't matter about healing that. So the immune system is turned off, all right? It doesn't matter if you have a cancer cell that's going to take 20 years to kill you. What matters is you stay alive for the next 30 minutes. So because of that, your immune system is shut off. Not a big deal for 30 minutes, but if you're going to be stressed out day after day, weeks on end, perhaps months on end, that's a big deal. Now the cancer is not controlled by the immune system. The infection is not controlled by the immune system. It can grow out of control. So stress increases the risk of cancer metastases. In addition, because it causes activation of the platelets. It's another reason why stress is prothrombotic. And when the platelets are activated, they have a tendency to form a circular enclosure, a blob, if you will, around metastasizing cancer cells in the blood. And remember, the immune system works by Braille. It feels everything. And so if there's platelets all over a metastasizing cancer cell in the blood, the immune system can't feel that cell. All it can feel is the platelets. So the cancer cell can hide from it, and it can pass on off to some distant destination where it might be able to implant and grow. Okay, so chronic psychological stress increases the risk of cancer metastasizing. And that's one of the reasons why, like, let's say a bunch of breast cancer patients, they do well with things that lower the stress. Being religious, maintaining a social support system, going to a support group, because that'll lower the stress. Give your problems over to God, and you will be healthier. Forgive everybody who annoyed you. All these things are part of lowering your stress with that attitude of gratitude. And those patients live longer. Okay, so a lot of people have written about that, and it's true. Okay, let's see what else about stress here. Stress increases your risk of cognitive impairment, becoming stupid, because the elevated cortisol causes increased release of glutamate in your neurons, in your brain cells. Glutamate's an excitatory neurotransmitter. It increases the activity in the postsynaptic neuron that receives the neurotransmitter as the postsynaptic neuron. Synapse is the space between two neurons. Okay, so that overactivation on your postsynaptic neurons means you could be anxious, you could be stressed out in a sense, you could have insomnia, you can't sleep because you're stressed out. Lack of sleep over time makes you stupid, and it increases the activity of the neuron while simultaneously causing vasoconstriction, clamping down on the blood vessels. Okay, the hormones elevated are cortisol and catecholamines. Catecholamines are like epinephrine, norepinephrine, same thing as adrenaline and noradrenaline. Well, those are vasoconstrictors. Okay, cortisol itself is a little bit of a vasoconstrictor, inhibiting endothelial nitric oxide synthase, meaning it decreases nitric oxide released by the arterial lining cells, the endothelial cells. So, it's a little bit of a vasoconstrictor. So you see the paradox. Although your brain's getting increased activated, like a limbic mode, it's getting decreased blood flow. And that's another reason why caffeine's bad. Caffeine increases the same hormones, and you have more of the same effect. What happens is you go from a cerebral cortex brain into a limbic brain. The brain has three parts. Imagine you're looking at it from the side, my fist here, okay? My fist would be the brain stem. My forearm would be the spinal cord. This is the midbrain, the brainstem. That's the reptile brain. I'm giving you the three-part brain of McLean here, okay? On top of that is a cingulate gyrus, like a Chicago Bears football helmet, letter C, okay? That's the limbic brain, the mammal brain, if you will, built on top of the reptile brain, so to speak, okay? And the limbic brain is instinctual, impulsive, emotional, okay? That's your dog, all right? And then on top of that is your cerebral cortex. So that's the three-part brain. Human brain on top, the last to have evolved or developed, so to speak, capable of sophisticated thinking, long-term, delayed gratification, pursuing a goal, able to consider the feelings of others, to perceive the long-term complications, okay? So anyways, when you're stressed out, you're not in that. You're in like a dog, like a wild animal. I got to run, I got to fight, what am I going to do, okay? So anyways, in that mode, you kind of shut down your cerebral cortex. Okay, let's see what else here. So stress over time can cause cognitive impairment, again, especially when it's chronic, day after day after day. Simultaneous increased activity of your neurons, excitotoxicity from the increased glutamate release, combined with cerebral vasoconstriction, narrowing of the arteries, decreasing the blood flow. Not a good combination. More energy demand, but less energy provided, so to speak. We talked about leaky gut, vasoconstriction, splanchnic shutdown. Okay, so that'll be it for part 1 of stress and health. We'll be back real soon with part 2.